take a look at some of the objectives that the bank had for this project. The bank wanted a flexible system which integrated with their current systems and one which could be expanded to bring in new applications such as word processing and electronic mail in the future. The bank also wanted a system that had a flexible data-driven design and also one which maintained the look and feel exactly of their current systems so that they could minimise their training costs. Also wanted to use 4GL technology so that they could develop systems more quickly. This system has a very tight deadline of June the 30th, and by the way, they sized 100% COBOL version of this project and it didn't fit within the time. So they're relying on Powerhouse to deliver the system about 30% faster than they would have been able to deliver with a COBOL system. So those are the objectives. Before we look at the design of this system, let's check out all of the tools that are to be used.
Welcome, ladies and gentlemen, to the rundown of languages used by the Northern Bank system. And right down at the bottom of the chart we have TPU. Yes, you thought it was an editor? Digital somehow managed to make it into a language as well. We have one TPU program. At number 5 we have C with 5 programs, and at number 4, all-in-one. Yes, you thought it was a word processor, but there are 40 programs in this system written using all-in-one's internal language. Storming up to number 3 just recently is COBOL with 50 programs. Yes, you thought it was dead, but it's alive and well in the Northern Bank system. At number 2, DCL, 80 programs in the system. And at number 1, an obscure little product called Powerhouse with 500 programs. Mind you, looking at some of the code, maybe we ought to credit the number 1 to QuickBowl.
The senior systems analysts at Northern Bank. Now let's expand on some of the issues that we came across when we were doing the physical. One of the issues that Malcolm raised there was that physical design was fairly tricky. The main reason for this was because of the interface we had to provide with Northern Bank's mainframe. The issues weren't just the normal ones of trying to interface with another denormalised system. There were other issues. For instance, in the mainframe system, you don't retrieve a record to amend it. You actually just put in key fields and the fields that you want to amend and then just send it off to the mainframe and the mainframe sorts it out. We came up against a lot of problems in the design when we were having to deal with that. In addition to that, all the programmers had just simply been on the intro course. That was the only knowledge they had of Powerhouse. So they were expected to then write mini-specs for some fairly complex processes with only a fairly minimal knowledge of Powerhouse. In addition to this, they were insistent that the system had to have the same look and feel as their old system. Now, this unfortunately led us to have to put in a lot of 3GL style features into some of the programs and held us up once again. Also, Digital insisted that we used RDB for the majority of the storage areas of the system. This added an extra learning curve for the people in the bank, as well as being unfamiliar with VMS and Powerhouse, and they also have to deal with RDB as well. Also added a certain amount of complexity to the programs. Another factor that caused us some problems was we were using CDD, and this actually restricted us in the data types that we were able to use in files. We weren't able to use the data types that we would have liked to have done, the data types we would have used in RMS files. It also meant that we couldn't use segmented indexes, which, if you've ever used Powerhouse PC, you'll know that it's not particularly helpful when you try to design systems. The issue which the bank had in mind was performance. The transactions that had to go through the system were extremely high, and we'll go into that in a little more detail. From our experience of developing Powerhouse systems, this is what we would consider to be the normal speed that a Powerhouse user would key. At this rate, the user would process approximately 100 transactions per hour in the Northern Bank system. as you can see, real users make mistakes. Now Digital have produced a special keyboard for Northern Bank, which has extra keys which have keystroke combinations programmed into them. This means that the likelihood of the keyers making mistakes is extremely low, because all the keystrokes are actually programmed in for them. Also, the actual keyers themselves are incredibly fast. The average between 2,000 and 2,500 transactions per hour. That's one transaction every 1.5 seconds. One of the prerequisites that the bank laid down was that no user could use more than 7% of the CPU. When we first ran the bank system using version 5.12, we found it was using 13% of the CPU. We then tried running it using version 6 and found that it was using 25% of the CPU. Something had to be done.
What do you reckon on all this powerhouse performance stuff then, Mike?
Well, it's usual Cognos amateurs they send in there. I mean, anybody knows if you've got a performance problem, you just pre-allocate all your global sections. That way all your screens come up really quick.
It's bleeding obvious, isn't it?
Oh, everybody should know that. And another thing, all these sequence numbers they need to allocate, they just told them in lock descriptors. Go off, get the lock, gets the next item sequence number, whoosh, no worries.
Any idiot knows that.
Yeah, it's alright.
I mean, I always hold my totals in arrays in memory. I mean, that's much more efficient.
Yeah, yeah.
Never mind this file stuff.
Everybody does
Who
it
needs
that way, don't
files?
they? Oh, don't they teach them anything down at Cognos these days?
I don't know. The cause of this problem is actually an undocumented feature of version 600, in that it uses character mode I/O instead of line mode I/O as in version 5.12. This change caused it to increase its CPU usage at these rates of keying by some 100%. This problem was...
Well, hello everybody, and welcome to the Northern Bank Project's Powerhouse Bug Countdown. And at the bottom of the chart tonight we have lock freeze error, which appears randomly on any terminal shortly after somebody's hit Control Y in a screen using RDB. Lovely. At number 6, well, you can tell an audit file to audit a master file, but will it get written? Nope. Number 5, ever tried doing a put in the exit procedure? Well, I wouldn't bother if I were you, it doesn't work. Number 4, we had all sorts of problems using the let verb in the process procedure against the field you're accepting. Just leave it alone, it's just not worth it. Number 3, data access error 0001EH30. Nice and friendly, huh? We call this one the Martini error, because it can happen any time, any place, anywhere. Although it especially likes to show its face during demos. At number 2, we have access violations. When these happen, Quick doesn't bother with boring old error handling, just chucks the user straight out the application. No worries. But at number 1, it has to be the 100% increase in CPU usage between version 5.12 and version 6. Marvellous.